Hi, and welcome to Dark Principles for DarkBASIC Professional. In today's special tutorial, we will be looking at another classic game reimagined in 3D. The original Space Invaders game was released in 1978. The game was so popular in Japan that it caused a temporary shortage of 100 yen coins. Today it remains a well-loved and played game. I am dedicating today's tutorial to my father, who passed away from skin cancer in 2007. While he wasn't a big game player, Space Invaders was one of the few he consistently returned to in various incarnations. It's even more fitting that I should release this dedication on Christmas Day, because it was his favourite time of year. This code example won't match the original creation. It will be fully 3D and based on primitives. These primitive objects can be replaced at any time with custom models, or you can use the CSG commands to make your own more detailed invaders. Because Space Invaders is copyright, I am only going to loosely base this game on its rules. For this reason, this tutorial will be referred to as Primitive Invaders, as is the nature of its media. It should be noted that this game was coded over the last couple of days, so its code may not be perfect. I have a large number of loops, and there are some inefficient moments in the game that could benefit from rewriting. However, the basic logic is sound, if a little wasteful. I've tested the game on a netbook class machine with an Atom 1.2 GHz processor and an Intel 945 graphics card. It runs well at a consistent 60 frames a second. However, you may find that if you add more advanced graphics and models to this game later on, that the code would benefit in terms of speed if you optimize the logic and decision making of the game. I will likely be releasing a final version of this code with my upcoming tutorial DVD project, designed to replace the current Dark Principles DVD. With any luck, this new DVD series will appear sometime in the latter half of 2011. I will also be providing other game examples such as 3D Bricks, Pong, and perhaps a 3D side-scroller game. As with all my intermediate tutorials, and because of the expected length of this tutorial, I will assume that the viewers of this example will have a reasonable knowledge of DarkBASIC Professional. This will be an unusually long and complex demonstration. Stopping to explain how everything works will likely turn this video into more than 4 hours long. If you are not familiar with some or all of the concepts and commands demonstrated in this video, then I strongly recommend that you read the DarkBASIC Professional Principles documentation under the help file, or invest in a copy of my existing Dark Principles for DarkBASIC Professional Foundation course, which can be found on Amazon.com. Open your DarkBASIC Professional editor if you have not already done so, and once you have, you want to click on the File, then New and Project. Then we want to give it a new file name. I'm going to call this Primitive Invaders. then just click OK. For those of you who watched my previous tutorial, which was the Turbo Table Tennis 3D demonstration, I used multiple source code files in order to help manage my code. I'm going to be doing the same thing here with the same sort of names. So if I create a new source code file in the same way I did in that tutorial, and I will call it environment again. And I'll also create a second one called functions. And as you can see, they have now opened in the tabs at the top. Again, as I did in my previous tutorial, I'm going to go through the basic structure of the program first, and then we'll fill in the gaps later on. So I'm going to start off this program by setting up all the data. This is going to be the variables, constants, and everything else that you may need in your program. And we're going to call this data setup. So type in go sub data setup. And we're then going to perform an environmental setup. This is our software environment, things like positioning the camera, setting up lights, turning sync on, etc., etc. So go sub environment setup. And now we're going to add a few settings that I've already predefined because I've obviously written this tutorial before rather than going on the fly. So under settings, it's always a good idea to mark your code so you know what things are. I'm going to set player.speed to equal 2. I'm going to set enemy, which is actually going to be set up as an array, a multi-dimensional array in fact, dot speed to equal 0.5. And we're going to set the display boundary to equal false. I'll show you how I can use false in a moment. And diagnostics to equal false. And then we're going to create our player object. So make player ob. And we're also going to want to actually sign an ID automatically. Now, in the majority of my tutorials up to this point, what I've been doing is simply calling object A1, object 2, well, object B2, object C3, etc. But what we're going to do in this program instead, because there's so much media to manage, is actually allow the program to manage the media itself. And we're going to create a function to do this, which I'm going to be calling next ob ID. So player, if I can actually type properly, ID equals next ob ID, open bracket, close bracket, and this will then be created as a function later on. Now again, I'm just going over the basic structure of the program here so you know what's going on in very rough terms, and then I'll take you through each of the functions and subroutines in turn, and we'll build up the program in the same way I did in my last example. Next, we want to actually create the enemies in the game. So again, we should always mark our code so we know what everything is. So create player object and create enemies. And again, we need a temporary object ID. So TID for short equals next ob ID, open bracket, close bracket. And then we'll actually call a new function which is make enemy, open bracket, TID, close bracket. Next, we're going to create our boundaries. These are going to be the collision zones in which bullets, invaders, players, and everything is not allowed to pass, or some kind of reaction happens when you actually hit it. Now, the list of assigned object IDs is going to be quite long here, so these aren't commands, these are actually variables that again I'm going to be creating in the main subroutines. So we're going to start off with boundary dot left equals next ob id, open bracket, close bracket, and boundary dot right equals, now because an object hasn't actually been created, the way this function is going to work is going to count the number of existing objects in order, and then it's going to get the next ID and return it to the program. But because no objects are actually being created, unlike with make enemy and make player, we can't automatically get a new ID. So what we're actually going to do is increase the ID we got initially by 1 for each new variable, or each new variable we set up to refer to each boundary. As you can imagine, the left boundary will be on the left side of the screen, the right boundary will be on the right side of the screen, top will be on the top, bottom. I'll be creating one called lose, which will be the lose area. This is if the invaders hit that area, then you automatically lose a game. And I'm going to be creating 3 more, which is going to be middle shield, left shield, and right shield. Now this might sound quite complicated right now, but once you see the graphics in place, you'll know why I've called them these common sense words. And as we go through the program, you'll notice how it makes it a lot easier to refer to whatever you're talking about. Whereas if I was just going to type in object IDs like 1, 2, 3, 4, then I'd have to remember what is boundary left, what is boundary right. By doing it this way, we can refer to it by language rather than by numbers, which makes a lot more sense in your mind. So again, I'm just going to be typing in boundary dot left, and we're going to be adding 1, and boundary dot top equals, now I can actually copy this bit to save myself a bit of typing. Add 2, boundary dot bottom equals, add 3. You can see what I'm doing. I'm just increasing the object ID by 1 each time. So again, boundary dot lose equals, we'll put 2 thingies in there. Add 4. Boundary dot middle shield equals 5. Boundary dot left shield, oh, I keep doing that, I keep forgetting that I copied the whatchamacallit as well, 6, and boundary dot right shield equals, keep doing that, equals 7. And this is basically going to be setting up all the IDs, so this is ready to go when we actually call the command make bndy, short for boundary. Open bracket, and we're actually going to pass a variable. You'll recognize it, it's one we've already created, which is going to be display boundary. Now what this is basically going to do is pass a switch into this command that displays the boundaries as 3D objects on the screen, or hides them, leaving them still able to take collisions but invisible on the screen. This is very useful when it comes to positioning everything, and we can disable it when we actually go into our main game loop and we no longer need to see the impact zones. Next we're going to proceed on to assigning some additional IDs which we don't need yet but will appear in the program. So assign IDs to other loop objects. By loop objects I mean objects that are created within the do and loop sequence. And we're going to have that as bullet.id equals next object ID, and enemy open bracket 0, 0 close bracket dot bomb equals bullet dot ID add 1. Now, if you're wondering why I'm putting those brackets in there, I'm basically creating a multi-dimensional array. If you don't know what that is, then you need to go up and read up on it. We will then proceed onto our main program loop. So the usual do, loop and sync. Oops, I can't type today. And then we're going to create several areas of the program. These are going to be fairly self-explanatory. Player control, open bracket, close bracket. This, of course, will control your player. So this area of the program is going to relate directly to the player. So player area and bullet control, open bracket, close bracket. And next we want to deal with our invaders, so aliens, just call that, and move invaders, open bracket, close bracket, and alien bombs, open bracket, close bracket. And next we're going to do a conditions check, so conditions check, excuse my spelling, I'm not really concentrating on it. Game check, open bracket, close bracket. And now we want some display information, so display information and game text, open bracket, close bracket. And we also want to add some diagnostic information as well, which I use in the development of my game. I won't actually need it as I go through the tutorial, hopefully, but I will add these in at the final part of the tutorial. So if you do hit any problems, you can type this in the last, and with a bit of luck it will give you some active information that tells you what's gone wrong with the program, as I've had to use several times during the development of this. It's usually things like object IDs not being right, or an object not existing, or a flag not being set, and that kind of thing. So this is our basic program. So just to recap, we're going to set up the data. These are going to be all the variables that I've typed in here that you don't know about yet. Environment setup, this is going to be the area where we set up our 3D environment, backdrop, sync, that kind of thing. We've got some general settings. The reason I put them there is because anytime I want to change the settings, I simply have to go to this area of the program, type in a new number, etc. Create player object, player ID, blah blah blah. This will create the player object. This is going to be the little ship that we fly around and shoot things with. Then we're going to create a whole heap of enemies for us to actually shoot. Then we're going to create the 3D boundaries, the invisible objects that aren't actually going to be seen in the screen, but tell the program whether or not they've been impacted. So we don't want things like the player going off the side of the screen infinitely. We want a barrier of some kind that it can detect and say, right, I cannot go past this point. The same is going to be for shields. When alien bombs come flying down, you want to be able to hide behind a nice shield, and we need a piece of logic that's basically going to say, if the bomb hits this, then delete the bomb and reset everything, and etc. And again, the same thing for our bullets. Once we hit an alien, which will actually be handled by the alien control area, but if we hit the top of the screen or we hit a boundary ourselves, then again we don't want our bullet going through it, because it will look odd and it won't be right. So this will set up all the boundaries for us. Then we just assign some additional IDs that are going to be used in the main program loop but aren't assigned quite yet. And then we're just going to go on to focusing on the player object and the bullet. We're going to then focus on the aliens, and we're going to focus on game checks. This is the area that says, right, okay, are lives less than 0? If they are, then end the game. Have you hit, have the aliens hit the bottom? If they have, then end the game, that kind of thing. So really, Space Invaders is a good game in many ways because it only has lose conditions. You basically keep playing it forever and ever and ever until you finally get overrun by the alien speed. It should also be noted that the reason I've set player speed here and enemy speed, player speed will remain fixed, but this gives you the ability to adjust how fast your ship moves at simply by typing the single value, and enemy speed will actually increase every time our aliens hit the side of the screen. So it will increase by 0. I think it's 0.1. I'll look at the code in a minute, but I think every time they hit the boundary at the side, it increases by 0.1, 0.1, 0.1, 0.1, and increases every time your aliens get lower. So again, this creates a difficulty factor. The longer you play it, the faster the aliens, the harder the game is going to be. So with any luck, this will be a fully operational game, and we will be ready to go as soon as the end of this tutorial has occurred. Because we've got the tabs up here, we don't really need this side panel, so I'm going to increase the area of my writing, and I always find the output window a bit distracting, so I'll just collapse that as well. And we shall then proceed onto the environment area, and we shall create a new subroutine, which was, if you recall, data setup. So data setup. And remember, you should always create constants at the beginning of the program. So I'm going to set up a number of constants here. So constant true as 1, constant false as 0. Now, if you recall, going back here, we had display boundaries false and diagnostic as false. We can now change these to true. I won't change the diagnostic, so I'll be leaving that to the end of the tutorial. But this will basically mean that the display boundary is activated. And you can see how it works now, because true is 1 and false is 0. So this is the same as if you said, if this is 1, then do this. If this is 0, then don't do this. I'm also going to set up a series of colors for quick and easy reference. These can also be copy and pasted into other programs, which is very useful. So constant, might as well copy that, save myself a bit of typing. So constant underscore blue. Please note that if you just use blue, the program won't compile. So for blue, green and red, you need to make sure there's an underscore or something else to make sure that it's not just blue, green or red. So 0, 0, 255 and red as 255, 0, 0, and green is 0, 255, 0. And this basically means that next time you type in the RGB command, you don't have to go 0, 0, 255. You can simply go underscore blue, which means you don't have to remember all those numbers. I'm also going to use a number of other numbers in this, so a number of other numbers. Cyan is 0, 255, 255. We also want purple. Can't go into Space Invaders unless that's purple. 223, 0, 225. I mean 255, sorry. We also want gold. So gold is going to be 193, 3, whoops, 160, 4. So I'm a bit tired, so if I make verbal slip-ups, you'll want to pay attention to the screen, because I might not say what I'm thinking, if you see what I mean. 255, 255, 0 for yellow. And we want a nice sort of violet for last, so VIOLET. 143, 0, 255. And this will basically set up our colours. So next time you wish to call a colour, you simply type in the name rather than typing in the numbers. Next we're going to set up a series of data types. So type ob, and we're going to have ID as byte. I won't be having more than 255 objects in the game, so I can limit it to that. Speed, whoops, I need to put these in lowercase, sorry. Speed as float. Flag as byte. So I'm just going to scroll down on my other screen. Oh yeah. Direction as boolean. Bomb as integer. Some of these can be reassigned as different values. Score, whoops. Score as word. Count as byte. And lives as byte. And that's the first type. Next type, sys. WRes as word. High res as word. End type. If you don't know what all this word and byte and integer business is, look up in the principles under the variable section and it will tell you everything you need to know there. And final one, type collision. Loose as integer. Top as integer. Bottom as integer. Left as integer. These could all be words actually, but I'm just going to stick with it. Left, right as integer. Middle, shield as integer. Don't actually have to type in integer. If I just left them without anything, if I just typed in shield or sorry, I've got middle shield and left shield. Whoops, I've gone up a page. Left shield. I could just leave it as left shield and right shield. And that would automatically be an integer by the uses of symbolism. But I like to define it in that way. When I skim over the program later on, I instantly know what things are, and the more consistent I keep my programming, I find the better my ability to understand what I'm doing. So end type, and we don't actually need time, so that's an experiment I did that failed, so I don't need to type that in. I know you won't know what I'm talking about because I'm reading off other code as well, but I did add another type here that I don't actually need. Now we're going to set up the global variable, so global player as ob, global, whoops, no, I did type that right, enemy as ob, global bullet as ob, global temp as ob. I'm not sure if I need that actually. I may come across it in the program. I don't remember it offhand. Temp boundary as collision. Oh, need the global as well. Global system as sys. And I don't need time either, so I removed all the timer codes from this in favour for a more primitive version. And next we're going to create an array. So dim enemy, open bracket 9, 4, close bracket as object or ob. system.wres equals screen width. So that means width resolution, open bracket, close bracket. And this is a system command rather than a function I've written myself. System.highres or hres, it should be, yeah, height res it should be, sorry, screen height. And as you can see, all this is doing is going to the system and saying, right, what resolution are you set to? And that means that I can position text and things on the screen without having to manually remember. It also means I have the ability to adjust the resolution to anything I like, and the program will automatically compensate for it. And now we're going to type in return. And that's basically it. So that's all our variable data set up. So just a quick explanation. Object will refer to things such as players and bullets and that kind of thing. System will refer to that particular set of commands, the system.res. Collision will will refer to the collision boundaries in the game as well. These could all be set to bytes actually, but I'll just leave it as it is for now. And dim will set up the array. This is where all our enemies are going to exist, and of course we've got some nice system commands to make life a little bit easier when we hit text commands later on. Next we're going to set up our environment. So we're going to create a new subroutine called environment setup, and we're going to have, oh, I need to type in return really, because I almost forgot it just now actually. Anyway, we need to type in sync on, sync rate 60, and backdrop on, color backdrop 0, all one word, Dan, not two. Hide mouse, auto cam off, and a randomize timer. Oops. What else do I need? I need to then position the camera. So position camera 0, 0, 300. I need to then point the camera at 0, 0, 0, which is the center of 3D space. And we're going to make light 1 and position light 1, 0, 0, 300. Now, I went a bit insane in the last tutorial, for those of you who did the Pong tutorial, or the 3D table tennis I should say. I actually tried adjusting the 0 light value, which is supposed to be the global illuminance, so that led to some minor problems with getting to illumination and things to work properly. So if you ignore what I demonstrated in that previous tutorial and make sure you make light 1 and then position that, you won't hit the same problems I did last time. So I was thinking in terms of camera and I should have been thinking in terms of light, and I typed in the wrong code. So I think that's about it then. That's it for the initialization code or the environment setup. So return, which I've already typed in, haven't I? Yes, I have. And that's it. Those are basically our subroutines, and that's all done then. Assuming I haven't made any horrible typing errors. There's no real way of testing at this point, to be honest, so that may turn out to be a problem. Remember to save your project by clicking on the Save All button. And we shall then proceed onto our main program area. Now what I want to do is disable most of my program so that I can enable it one at a time as I start producing the program. This basically means that I can compile to see how I'm doing at different stages rather than just typing it all out in one go and getting myself into a horrible pickle, which I assure you I will. So what I'm going to do now is highlight all this code, and this is quite a useful little button here. If we click on that comment section, that basically means everything there is commented. Now I'm going to uncomment certain areas, such as the sync and loop, which I need. I'm going to uncomment the do, and this will ensure that we do go into some kind of loop. And oops, my screen has a nice blur effect there. Bit of a problem with the IDE, sometimes it blurs the text, but it doesn't last for too long. So you'll notice now that the display boundary equals true is now blue, and it will refer to the constant that we've already created. So that's blooming useful. Now what we're going to do is start off very slowly, and we're going to start off by creating our player object. And the first thing we need to do before we do that, if we uncomment this area here, and now we're going to create our next object ID function, which is going to work out the next free available ID slot for us. So hang on a sec. So we're going to create our first function of the program. So function, and we want next ob ID, open bracket, close bracket, and end function, which it kindly provides for me. ID equals 0, state equals false, repeat, whoops, it's already put the until, I never quite get used to that, repeat until, whoops, I'll get myself into a pickle. Right. Concentrate on what you're doing. Until state equals true. So basically the repeat and loop will continue going in the loop, counting through our free object IDs right up until it turns out an object is true. And that will make more sense in a moment. So between the repeat and loop, do inc ID, because objects always start at 1, so you need to make sure you put the inc at the beginning of the loop. If object exist, open bracket ID, close bracket, equals 0, then state equals true. Now what I'm basically doing here is getting the program to say, right, ID starts at 1, then 2, then 3, then 4, then 5, and as soon as it turns out an object doesn't occupy that ID, then it will return a 0, and once that happens we then set the statement to true, and we are actually going to return the ID variable back into the program. So anytime I say variable equals next object ID, it will automatically retrieve the next free object ID slot that it detects. So very useful for when you're automating the management of large groups of media. For instance, throughout this entire program I'm going to be creating a play object. I'm going to be creating 50 alien objects. So I'm going to create 1, 2, 3, 4, 5, 6, 7, 8 boundary objects, and of course there's going to be 2 other objects which are going to be the aliens, bombs, and our bullets. So this is very useful again for automating the generation of IDs, and it's something I've used quite a lot in my DarkBASIC Professional career. So now that that's done, we need to basically make sure that it works, make sure it doesn't produce any errors. So if we just press F5 and see what happens, and this is probably where my spelling errors are going to turn up. Oh, we're doing well. So my first compile, it won't actually produce anything on screen because we haven't told it to, but the fact that it's compiled and running is a good sign. So if we then close that and save our project. And next we're going to create our make player object. So this is actually going to be the bit where we actually create something to put on the screen. So we're going to uncomment that and return to the functions. Because player ID is a global variable, it means I don't actually have to pass it into the function because it's going to apply to all parts of the program. So what was the name of that again? Sorry, it was make player object. So function make player object. Got the spelling right? Yep. And now we're going to start typing in our stuff. So make object box player.id 25, 15, 10. And I just realised I use shorthand. So actually it's a good idea sometimes if you've typed it in here just to copy and paste it. And that way, if you're an idiot like me, you won't end up using shorthand in some places and longhand in others. So now if we compile this just to make sure that the function is working properly. So there we go. We now have a little box in the middle of the screen. And we're now going to proceed onto a little bit of wizardry. So brush equals next ob ID. Now the reason I can call that within the middle of the program is because our box is already created. So we're then going to go make object box brush, and we're going to set that to 5, 5, 10. And now we're going to now what we're going to do is basically carve an area out of the block we've already made to make a more interesting player object. We could just leave it as it is. We could just have a box going left and right over the screen, but it's not very attractive. So we're going to use the CGS commands to help carve big chunks out of it. So we're going to position the object, and we're going to give it the position of 10, 5, 10. Remember to refer to the object ID, as I've forgotten here. And this will then move that object into the corner. So if we also colour that object, brush, RGB, this is where our useful little doodads come in. So we're just going to colour it red, and if we compile it again, you'll notice where the box is now overlaid. So what we're going to do is basically take that little red chunk out of our player object. So we don't actually need that, so we can get rid of the player thingy. And then we can go perform CSG difference player.id, brush. And what we're basically doing is subtracting that little square away from our player object. We're then going to reposition that object again. So position object brush, and we're going to give it the position of -10, 5, 0. So we're going on the other side of the object now. Because our object occupies the center of the screen, which is 0, 0, 0, we can go into minus and negatives to get from one side to the other. And again, we're going to do a quick color of the object here, just to show you what I mean. Brush, RGB red. I shouldn't have deleted this line, really. Should have just kept it in there. Never mind. We'll now compile and I'll show you what I mean. There you go. Something wrong there. 2 seconds. I've got the coordinates too high up. That should be 0. So it should be 0 on the Z-axis. My apologies. So we'll try that again. And as you can see, this isn't what showed before, but as you can see, a chunk has now been taken out of that object because I got the coordinates wrong. I raised it by 10 units. It made no difference whatsoever. So I fixed that error now. And we'll copy this command and put it over that. And we also want to give our little spaceship a firing nozzle at the end. So we're going to just read the screen. Where am I? Position object brush. And we're going to give it the location of 0, 10, 0. And we're going to perform a CSG union, which basically means adding the object to the other object. So again, player.id, comma, brush. And that should be a little brush, not a big brush. Don't know why I keep typing in bush. And finally, we're going to delete object brush. So that's now deleted, and that frees up that ID slot because we don't need it anymore. And we're then going to position our object, our player object, at the bottom of the screen. So position object plyr.id, comma 0, comma minus 150, because we're going down the y-axis, and 0, and we're going to give our object a nice color. So color object player.id, comma RGB, open bracket, underscore blue, close bracket. And that should, hopefully I haven't typed in anything wrong here. This is why it's important to compile as you do each section of the program, because it means it's a lot easier to look through that short area of code than it is to hunt through an entire program for one line of code you've mistyped. And as you can see, I make plenty of those mistyping errors. But as you can see, we now have our little kind of Space Invader-ish style ship at the bottom of the screen, and it looks like it's got a little nozzle that you can fire bullets out of, and of course you can move it from left and right across the screen. So that's how we create our player object using the CGS commands to make a slightly more interesting primitive. So now let's return to our main program and see what's next to do. So next we want to create our enemy objects. So we're going to uncomment this area here. And we don't need to deal with the object ID, that's already done. We're going to copy that and put it into our functions area. Function. And if I press enter, it will then end function for me. And this is where we're going to start creating lots of loops and case selects and that kind of thing. So we're going to create some nice enemies. So function enemy, and we're going to give that the ID of ob, which we'll do, refers to object. And we're going to create our first loop, which is going to be for x equals 0 to 9, and then for y equals 0 to 4, and that's going to be next y and next x. So we're literally counting up x from 0 to y, sorry, from 0 to 9, and then up y 0 to 4. So it's giving me another next there. Very good ID, but sometimes it does tend to be a bit too smart for its own good. Or for my own good, rather. And what we're going to do then is go enemy, open bracket, x comma y. You can see where I'm going with this. Dot flag equals true. Now this is a bit of the flag is basically going to be used in a little bit of logic that says, does this object exist, yes or no? Unlike with the brush object earlier, when a bullet object is going to hit our Space Invader, instead of deleting the item, what we're going to do is hide the area, and then we're going to take it out of consideration for the program. So if any enemy at the coordinates of x and y equals false, that means that any logic we write later on, when a bullet comes into contact with it, it's just going to ignore it. It's not there as far as the program is concerned. Enemy and dot... Sorry. Am I missing something here? No, because I assigned the object to the actual function. So enemy x comma y dot ID equals ob. So basically that's assigning the object ID we created with the next ob ID, which we then put into the function as the ob variable, which we're now plugging into the enemy x and y.id. And now we're going to make an object. So make object box obj 20, 20, 10, and this will actually create our Space Invaders. So basically, because this is Primitive Invaders, not Space Invaders, we're just going to be attacked by a series of cubes. You can replace these with any models you like later on. You can use CSG commands to alter their appearance. There are a number of different things you can do. You could even just set up a series of planes or very thin boxes and simply paste a graphic of a Space Invader on top of it. But I'm just going to use cubes because, to be honest, I quite like it. It looks quite good, I think. So we're going to stick with the cube. We're not going to do anything fancy. And then we're going to position the object with a little bit of math. So position object, ob, comma, 135 minus, open bracket, x times 30, close bracket, comma, 125 minus, open bracket, y times 30, close bracket, comma, 0. So we're basically, according to the current x and y count, then this will then position the objects differently. So we're going to start at the position of 135. We're then going to subtract whatever x is times by 30, and then we're going to do the same thing. In fact, that should be add, shouldn't it? No, that is subtract, sorry. Just checking my own math here. And we're going to give it the z coordinate of 0 because while this is a 3D game, it's going to take place in a very 2D way. So we're not really going to deal with the z axis at any point in this tutorial. And once we've done this, we then need to increase the value of obj. Otherwise, the next time this program cycles round, it's just going to have the same ID that we originally signed it. So this is more or less the same way that same thing we did with the boundary.left, boundary.right, boundary.top. I just typed in +1. What we're actually going to do is increase the object value by 1 each time this loop cycles, and that will give each object an original ID when it comes to actually running the game. So what we need to do now is scroll down, and that should be it. That should be all we need to actually create our initial enemies. So let's give this a compile and see if, again, I've typed in any horrible spelling mistakes or my math is wrong. And there we go. So we now have a nicely centered group of Space Invaders, and these are going to be the items that come down the screen and you've got to shoot. So as you can see, this is actually starting to look more or less like a Space Invaders game now, which is quite good. So we're going to exit this program now, and once again we're going to save. Now that's a bit boring, really. We want some colours, don't we? So I'm actually going to create a select and case statement here to help make that a bit easier. So select Y, because we only want to go down rows. We don't actually want to, is it rows or columns? I can never remember which way around it is. But either way, we want to go down each row of Space Invaders or Cube Invaders, and we want to give them a unique colour. So by selecting Y, we can do that. And now we're going to select multiple cases. So case 0, colour object enemy, open bracket X, comma Y, close bracket, .id, comma, RGB, and we'll give the top one a nice cyan colour. I like cyan, so we'll go with that. And now we're going to type in end case, then case 1. So you can see what's happening here. As Y counts up, we're going to go through these different cases and then assign different colours to that row of Space Invaders. So case 1, colour, whoops, I'm British, so I keep typing colour as we think it's supposed to be typed in. So colour object enemy. In fact, actually, I can just copy that line rather than pasting it all the time, and I can just give it a unique colour each time. So we'll give that a nice violet colour. You can, of course, change the colours to anything you wish. end case, case 2, end case, and we will give that a nice green colour, I think. I like green. And case 3, end case. You can see how this is working now, can't you? Whoops. Even if I can't type. Right, paste that in there, and we want to give that a nice yellow colour. And I think we'll make the final one a nice gold colour. So case 4, end case, put a space in there. And we shall give that a gold colour. I quite like gold as well. So there we go. We should now have some brightly coloured Space Invaders. Now, just in case the case does go out of range, I will quickly compile that to make sure that code works. I've forgotten the end select, haven't I? Whoops. So end select there, that should make more sense. Right, what have I typed in wrong? Let's have a look at the output panel. Could not determine type of parameter. Oh, I must have typed it in wrong back here. So if we go back to our environment. Oh yes, I put a full stop in green. Whoops. Okay, let's try that again. And there we go, we now have some differently coloured Space Invaders. And again, you can adjust these to any colour you want. If you ever want to know what specific colours are, then just search the internet for RGB in a colour, and you'll get loads of websites with the 3 colour codes you need. So we'll exit that. And again, it's starting to look more like a game. What else do we need to do? And that's it. We have basically made our Space Invaders. So we're just going to tidy that up a little bit. And end function, we don't need to return anything. So our objects have been made. We've coloured them. Oh yes, we should always put in a case default. So case default and end case. Now, because I expect all my all my my brain's going. Because I expect it not to exceed the range of 0 to 4, what I want to do is put in an unexpected error function, and then quote the name of the function that the error occurred in and the variable that it applies to. This saves a lot of typing in the long run, because every time I do these case statements, I always make a case default, and I always use this function to report what's gone wrong and what the variable is used. And that way, should anything go wrong, should for whatever reason I type in something like 4y equals 5 instead of 4, and it goes to the the 5th level, and it produces a result it doesn't expect, then this will then go to the case default option and ensure that it's reported to me, that I know what's going on and I know where the error is occurring in this particular case. So unexpected error, which is a function I'm going to write in a second, and we're going to pass in the variables make enemy, or should say string really. So I'm going to pass through the string make enemy and y, and you'll see why I've set up the command like this in a moment. You don't have to add this in, it is optional. So I'm now going to type in function unexpected error, open bracket, function name, string, comma, var name, string, and a close bracket. It will automatically give me the nice end function, and this is where our system.wres comes in. So this is our first example of using text with that option. So center text system.wres/2. So what we're doing is we're taking the middle of the screen along the width, and then we're going to take the middle of the screen along the height. So height res divided by 2, and because it's center text instead of just text, it will center the text nicely in the middle of the screen. And error in add a space, then in quote put in the plus symbol, function function name string plus we need a space plus var name string plus space is out of expected range. So anytime we have a case statement set up and it falls outside the range that I expect that case to be able to handle, then it will stop the program, give me this error, and I can go back and see what I'm doing wrong. So sync, this makes sure the text is written to the screen. Wait key, this waits for me to press a key, and then we want to end the program because an error has occurred and I need to go back and do some debugging. So you don't have to add it in, but it's a useful thing that I put into most of my programs because it saves quite a lot of troubleshooting, I find. So we'll save that there, and we'll do a quick compile to make sure everything is hunky-dory. And of course I've typed it in there wrong. So what have I typed in wrong? I put in unexpect, not unexpected. So we'll try that again. It's very good that these things show up as blue, otherwise I would be lost. There we go. So the program is working as I expect at this point in time. Okay, now we've done that, again we need to return to our main program script, and we need to see what we need to do next. So next we need to set up the boundaries. So we're going to uncomment this section here, and yep, that's all I need to do. Save that, and now we need to write the make boundary function. So we'll just copy that, go to functions and create a new function. I like to create them in order they appear. If you looked at my original source code, these functions are all over the place because I have bright ideas and I change the positions quite frequently. Now I'm actually going to give this the variable name of set boundary, and if you're wondering why this has appeared, that's basically so you can collapse it. I don't know why it doesn't always appear for the others, but it's just one of those little quirks of the IDE I tend to forget about. So when I initially made the game, what I did was create a large reference box, which gave me an idea of how big the screen was. I just resized it until I had it roughly filling the screen, and the size I came up with was make object box. I'm not sure if I can use that function directly in it actually, so next ob id, open bracket, close bracket. It probably won't work, but we'll give it a go anyway. Make object box. The numbers I came up with were 470 and by 350, and I gave it a depth of 2. So we'll try compiling that and see what happens. What's gone wrong there then? cannot understand line 21, so boundary equals... Have I typed that in right? You often miss these small errors, but you'll notice I've put a comma there where I should have put a full stop. So we'll try that again. And there we go. So we've now got, you'll notice that there's a big grey area that almost perfectly matches the screen, if not actually perfectly, I would say. And that I use that as a reference initially to judge how much space there was to work with and the field. So I now know I've got 470 units across and 350 units down. Divide that by 2. That means 350 divided by 2 is 175, I believe. I better check that actually because my brain isn't working entirely well right now. So 350 divided by 2, yeah, 175, and of course 470 divided by 2 is going to be 235. So we can define those two numbers as the maximum plus or minus coordinate we can set for our objects. So we don't actually need that, but it's good to know you can actually use a function directly inside here as well. So what I do now is comment that out. And just give it the name of, or just give it a little comment of reference box. So I know what that was in the future and why I disabled it. So you've got a highlight, okay. Okay. And there we go. So now we're going to proceed on to making the rest of our boundaries. We're going to start off with the left boundary. So the reason I use common sense words rather than numbers is because it makes it very, very much easier to read in the program. For example, if I type in make object box boundary dot left, then I know at a glance that that's boundary dot left. That is the left side of the screen. So I don't have to remember whether it was object number 12, 13, 512 or whatever. I just know from the name and I can reference it quickly and easily through all parts of the program because it's a nice global. So make object box boundary. So again, we knew it was 350 units high, and we're going to give it the width of 10 by 10. And we're going to then reposition our object. So position object boundary dot left, comma 235, comma 0, comma 0. And this will then appear on the edge of the screen with a bit of luck. So we'll compile that and see if it works. Oh, what's gone on there? Global boundary as collision. Okay, the reason that didn't work is because I didn't actually close the application, so we'll try that again. Okay, let's try compiling it again. There we go. Oh, legal number at 209. So what have we done wrong here? It's fairly obvious when I actually read it. I haven't uncommented one of the lines. So again, we'll try that again. This is why it's important to test at every stage of the way, because these errors do keep creeping in. There we go. So now we have our boundary along the left-hand side of the screen. So as you can see, that is occupying quite a nice left area as well. So if we return to our function now, and we'll make the right one. So make object box boundary dot right, comma again same size, 350, comma 10, and position object boundary. Oh, I put a cap lock in there, or cap. Shouldn't really. Right. 10, comma. All right. This is going to be minus 335, 0, compile. And I've seen a little error I've made there already without actually needing to compile. So let's try that again. So now we now have the boundary box at the left and right of the screen. And now we need the top and bottom. So make object box boundary dot top 470 10, 10 position object boundary dot top comma 0, 175, 0, and we'll copy that and alter it. So boundary dot bottom and bottom. I probably just copied a mistake I made in the last one, but never mind. And we'll see if that works. So now we have a nice border around the whole edge of our game, and these are going to be the collision boxes that we hit, and in order to stop bullets and stop our movement and stop the aliens' movement and stop bottoms falling to the ground, sorry, stop bullets falling to the ground and stuff. So we'll exit that, and we're going to then create the shields. So we then want to create some shields in our game. So make object box boundary dot middle dot underscore shield comma 50, 5, 10, and position object boundary dot middle underscore shield comma 0, minus 125, 0, and we're going to give it a nice color as well. So color object boundary dot middle dot underscore shield, too used to dots, RGB, and I like purple, so we're going to go with purple now. And I'm going to copy that twice more. So we've got right, and right, and then left, and left. And now we're going to change the positions. So right will be as I've worked out earlier. Oh, need to scroll down my screen a bit. So right is going to be positioned at alright, we want the same Y position, and we want to go for 150 and minus 150. So 150 on one side and minus 150 on the other side. We'll give it a compile and see what I've done wrong this time. There we go. So we now have a game that's looking quite like Space Invaders or Primitive Invaders. So we're going to close that window there, save it, and the final boundary we need to plug in is going to be the lose zone. So this is the area in which if any of the aliens touch this box, then the game is basically over. So make object box boundary dot lose comma 0, comma oh no, not 0, sorry, 470, comma, we give it a wide depth of 50, comma, and a depth of 5. And we're going to position the object, so position object boundary dot lose 0, comma, minus 150, comma 0. And we're going to give this object a color, so color object boundary dot lose comma RGB open bracket underscore red close bracket. And if we compile the code yet again, all right, what have I done wrong? No O. Okay. And there you go. So that red zone where just underneath the shields is going to be the area in which the Space Invaders will hit. As soon as it hits this area, we'll write a little bit of logic later on that says game over. Play. Do you want to play again? So, but these are just reference. In the actual game, it's going to look like the original black screen without all the borders and things, and the way we're going to do that is we're going to add an additional function. But first of all, I'm going to increase the indent on those. I don't need the indent that much, so that'll do. Never mind, we'll just leave that as is. Looks a bit bad, but never mind. And okay, the next function I'm going to create is display a boundary, open bracket, set boundary, close bracket. Have I typed that in right? Yes, I have. So now we need to create a brand new function. And we're going to have function display boundary decision and select decision, because I do like these case commands. Case true. If the case is true, then show object boundary dot top, show object boundary dot bottom, show object boundary dot left, show object boundary dot right, show object boundary dot lose. We're not going to include the shields because they will always be visible. They are part of the graphics of the game. And next we're going to case false, hide object boundary dot top, hide object boundary dot bottom, hide object boundary dot left, hide object boundary dot right, and hide object boundary dot lose. And end case, and we're going to do our final case default. Unexpected error, open bracket quote, display boundary and decision. And if anything goes wrong, or rather if the decision goes outside of that range, we can then quickly and easily identify it thanks to this little doodah. And select. And there we go. So basically what's going to happen now is set boundary will be set to, if we go down here, set boundary is going to be actually be set up at the top of the program. So remember, we originally created this little variable here. Now at the moment we got it set to true, so if I compile this program, in theory, providing I haven't made any fresh mistakes, which I have, right, I need to put a dot in there, try again. The boundary is now showing. Now if we return to our program and, whoops, that one should be, and we take that to false, this basically means that it should no longer show. And there you go. So that's a quick and easy way of turning off the boundary reference areas. So when you're troubleshooting, if you think that an object is going beyond the boundary, then you can turn it on. You can check visually if this is the case, and then you can go back and fix the problem. And then you can disable it again simply by altering the true or false statement. So I'm going to leave it on true for now, because we'll use it as a reference when we come to writing our collision commands later on. Now once again we're back in the main area of the program, and we're going to see what needs to be done next. So these objects need to be assigned, otherwise the next section of the program will not work. So remove the comments from that, and that will set up our bullet ID and our enemy.bomb ID. Now the enemy.bomb ID is, as it suggests, a bomb. Now you'll notice I'm not using X and Y, and I'm not using multiple one. This is because we're only going to be using one bomb, and we're only going to be using one bullet. As soon as that bullet hits the ground or an object, it vanishes and then is fired again. So this is basically going to be a one bullet at a time firing game. You can create additional bullets, but it creates extra programming, and the game is quite good as it plays at the moment. But again, you can add this in later if you wish. So we're going to proceed onto the player control next. So we're going to remove the commenting from that, and then we're going to copy that into our function area. Whoops. And we're going to, so this has already been created, or the player objects and stuff has already been created. So this is purely for the two bullets that are going to be created within the game loop, then deleted, then created, then deleted, etc., etc. So we're going to function, go to the end. So function player control, and I'm just going to make a minor spell correct. There should be T there for my own satisfaction. So player control, and we're just going to do a simple if left key equals true, then position object player.id, comma object position x open bracket player.id. So we're just getting the position of the player object, and we're then going to add player speed to it. So add player.speed, and this basically moves as fast or as slow as you define with the .player.speed setting we use at the beginning of the Primitive Invaders program. So if we go up here, you'll notice the setting is there. So player.speed equals 2. So we're basically adding 2 to the X position anytime left is pressed. So next we need to go and because Y and Z don't change at all, we simply need to report object position Y open bracket player.id comma object position Z open bracket player.id. And then we need to copy this. And we're going to turn that into right key. So if right key equals true, then we need to subtract instead of plus. And if I compile this now with a bit of luck, yeah, as you can see. Now it's very jerky and blocky on this because I'm capturing video at the same time. If you see the video at the beginning of the video and at the end of the video, you'll see it's lovely smooth gameplay. So this is only because I'm screen capturing at the same time. But as you can see, left or right is going right and left is going left. So that's all working as it should be. Now the biggest problem is that if you continue going right, then you're just going to pass off the edge of the screen. So we need to add some kind of limiter there. We need to have something that stops it from going past the boundary we set on the left hand side. And that's what we're going to write in now. If object collision, open bracket player.id and a boundary.right equals true, then we want to reposition the object player.id object position X, open bracket player.id, and we want to subtract, don't we? Hang on a sec. Yeah, we want to subtract the player speed, so subtract player.speed. So basically, as we're moving right, we then take it back to the last position where it wasn't in contact. So if object, so basically what happens is we pass into the collision box on the right hand side with this command, and then once that is detected with this command here, we then move it 2 units in the other direction, so it appears as if it never passed through the barrier. So we're just limiting our movement there. Then it's object position Y, player.id, object position Z, player.id. This is, to be honest, one of the areas where I could simplify my coding, because I haven't really been through this code that many times. I haven't rewritten it to optimize the code or reduce the amount of typing required or anything like that. So this was literally finished, well, as it is. I finished it a couple of hours ago. So we now, of course, need to write a rule for the other line as well. So copy that, paste it, we want left instead, and we then want to plus, not subtract, and we'll see if that works now. So I'm assuming you're compiling at the same time I'm compiling, so we'll try the left hand boundary first. I could actually speed it up a bit, but oh no, that's gone through, so that's wrong. And on the other hand, I can't come back, so I've probably got those the wrong way around. Let's try that. Ah yes, because here I've got left and right, and there I've got right and left, so I had it the wrong way around. So we'll try that again. Probably should have adjusted the speed of the player before starting recording. But as you can see, it doesn't go through that barrier, and I'm holding down the key quite nicely, so we'll try in the other direction as well. I'll just bring out the music, Chariots of Fire. But as I'm already committed, it's already there, there's not much point in There we go. So again, we cannot go through the wall. So that's produced our nice little limiter that's prevented us from exceeding the bounds of the game. So again, we'll save there. And that's basically it for player control. So if we go back here again, scroll down, and now we're going to do bullet control. So we're going to make a brand new function again. Function bullet control, end function. Right, the first thing we need to do is check whether or not the bullet actually exists. We know it doesn't because we haven't created it yet, but we will do it as part of the course. In fact, actually, I may have forgotten a command. Yes, I have. No, sorry, that should have fallen under the previous one. So player control should actually have another command here that says if space key equals true, then we need to perform the command make bullet. And that makes more sense now. So we don't need bullet control yet. We need to make the bullet first. So just scroll down to my other screen. So function make bullet, and function. Okay, so if object exist, open bracket bullet dot id equals false. So if the bullet doesn't exist, we need to create one. So make object box bullet.id, 4, 12, 4. Gives it a nice dimension, I think. Then we need to position object bullet.id, object position x, player.id, object position y, player.id, and we want to add 13 to that because the way it's, if you don't add 13, it looks like it's coming from the center of the object, and that looks very odd when you're in gameplay. But by giving it an offset of 13 units, it appears to be coming from the nozzle of your spacecraft. So as you're going left and right, it doesn't look so bad. And object position z. So all pretty standard. Player.id, and that then sets the bullet into more or less the same position as your spacecraft with a minor alteration. So that's Z, Y, and X. That's correct. And now we need to color our object. So color object, because no one likes a grey bullet. Bullet.id, comma RGB, and we give that a red because it's a bullet. So we give it the color of red. And end if. And we'll go on straight to the bullet control then, otherwise it's just going to appear whenever we hit spacebar and then nothing is going to happen. In fact, actually we should test that, so I'll just compile that. Change my mind mid-decision. So don't actually know if it's created it or not because I've left the bounds on. Right. That's right. So let's set that to false for now and try again. Oh, hit debug by accident. Right, let's try again. As you can see, I've been recording constantly up until this point, so I'm getting a little bit tired, having only finished programming each day as well. So if I press space, there we go. So we demonstrated that bullet is being created, and is being created out of the nozzle rather than the middle of the object, and it's being created with a nice what's the word? A nice leeway or whatever, a bit of distance between the shield and the creations. That's also what we want to check for. So we'll turn that back on to true. So that's our bullet actually made. So now we want to actually control our bullet. And this is where it gets exciting. We can start killing things. Okay, so if object exist bullet.id equals true, because obviously the bullet has to exist before we can do anything with it. Position, whoops. I have to admit, I find this feature of adding in that quite annoying. Right, object true. Okay, position object bullet.id, comma object position bullet dot, what am I doing? Object position X, open bracket, and bullet dot ID, object position Y, and bullet dot ID, and we want to add let's set it so it's the same speed as the player as well. So if you increase the speed of the player, the bullet increases as well. So why not? Oh, I could create another I could create another doodah actually. I would just set it for 2 for now. So if you want to adjust the speed of the bullet, you can do that later. So object position Z bullet dot ID, and that in theory, providing the bullet exists, should then move upwards. So we'll give that a go. So if I press the space button, as you can see, the bullet is now flying upwards very slowly, because again I'm screen capturing and this is a slow laptop. Unfortunately my desktop died, so goodbye 8800 GeForce and hello Intel 4500. Oh gosh. Anyway, we now need to start setting up collisions and things. So we want to actually be able to destroy our enemies, otherwise it's not much fun really, is it? So now what we need to do is create... Alright, we need to stop that end if there. But we don't actually need an end if, we can just do a than, can't we? So we get rid of that. So it's all one line of code now. So that's positioning the object, that's correct. And next we need to go for x equals 0 to 9. Then for y equals 0 to 4, and I'm going to get rid of that next. Next y, next x. So we're doing a loop now. We're basically going to be looping all the way through our enemies. So if enemy x comma y dot flag equals true, if object collision between, whoops, I put id. If object collision bullet dot id comma enemy x comma y dot id equals true, and we need two end ifs. Then basically we want to set the object flag to false. So enemy x comma y dot flag equals false. Now what we're basically doing here is marking this object as hit, which basically means it should no longer be displayed on the screen and it should no longer be included in these collision decisions. So as soon as this equals false, that means this if statement here will no longer have any effect on it. We then need to hide the object, so hide object enemy x comma y dot id, and we need to delete the object bullet. So delete object bullet dot id, and we also want to increase player dot count. Now what this variable does is count how many aliens we've hit. So as soon as this total hits 50, we need to take an action, reset the scene, put all the aliens back, unhide them, and we will do that with another function later on. And we also want to increase the player score. So inc player dot score by 10, and that's it. Then there should be, how many end ifs are there? I think I've left out a logic command there, so I'm just going to add another end if. Alright, so I also did another if bullet exist. So if object exist bullet dot id equals true. So what we're basically doing here is setting up three conditions. So if the object exists, or if the bullet exists, then we go on to the next if statement. If it doesn't, then there's no point going on to the next if statement. If the enemy flag equals true, this means it's alive. This basically means we then proceed on to the next if statement. And if there's a collision between the bullets, we need to change the state of affairs. We need to delete the bullet, and we need to remove the enemy from play. So we set the flag to mean false, which means this will no longer have any effect. We delete the bullet, which means this will no longer have any effect. And if these don't have any effects, then it's never going to reach as far as the collision. If I didn't have this in here, then basically it would hit the object collision, it would say bullet doesn't exist, and throw up an error. So these three pieces of logic are vital if you want an error-free operation of the program. So just adjust that. Again, it makes it a bit easier to read when you format all this properly. So we'll save that there. Now, because of the speed capturing issue, I need to speed up this bullet, so I'm going to set up a new variable now. So we're going to go back to our main program. We're going to type in bullet.speed equals, and we're going to give it a nice 6 for now. It isn't essential. You can ignore it on your screen because you will be using this game at full speed, but for the purposes of this tutorial I need to be able to speed up the game elements to compensate for the slower machine capturing. So we need to go into environment as well, and I need to go into the, where was bullet again? What was bullet assigned as? Bullet was assigned as object. So I need to sign here. So we've got speed, so I don't know, bullet speed will do, and we'll set that as a byte, which is 0 to 255, which is more than enough. So if I go here now, and we'll adjust this to add bullet.speed, or is bullet speed, wasn't it? So bullet speed. I would put BS, but I'm not sure YouTube would appreciate that. So we'll just try compiling that. Oh, before I do, I need to adjust that too. So I've just altered the speed of the bullet with bullet.bullet speed. So now when I fire it, it should be non-functional at all. So what have I done wrong? I know, I didn't set up the initial variable properly, did I? So that should be bullet.bullet speed. So actually I could just leave that as speed, couldn't I? I'm being a bit of an idiot here. So I'm completely backtracking now and I'm removing the bullet.speed. I shouldn't alter these programs in mid-tutorial, it only ends up in problems. So with that lesson in mind, I shall now try it again. That's better. So as you can see, it's now a lot faster, and as you can see, the bullets are now hitting the squares and they're vanishing, and they're able to go through the previous squares as if by magic. So with that long and rather roundabout way of doing it, which I apologize for, as you can see, the enemies are now being destroyed, and as you however, the next problem you'll notice is that the bullet just went through the boundary at the top, and I can't fire anymore because the bullet is going off into infinite space. So I need to set up another limiter for the top boundary there. And while I'm here, I'm quickly going to increase the speed of the play as well. So if we increase that to 6, and we'll also increase the enemy speed to 2. So when it comes to the objects actually moving, it should be 0.5. Remember that. It's going to be very fast at 2. So now we need to limit the bullet. So we're going to go back to our function. And this is all done now, so it's quite happily deleting the bullet, it's returning the bullet to us, it's hiding the object correctly, it's marking the flag, that kind of stuff. And we now need to add a limiter to prevent it from going through the top boundary. So again, we need to do a check for the bullet because this section of the code may have been done already, in which case the bullet may have been destroyed. It may not exist as an object. So if object exist, we need to keep doing these checks. Bullet.id equals true. If object collision between bullet.id and boundary.top, see why it's easier to remember the names. So bullet.id, boundary.top. In fact, we have some other things we also need to compensate for, because we've got the 3 shields and we don't want our bullets going through that either. So if that equals true, or object collision bullet.id, comma, boundary.middle shield, equals true, and we then need to repeat that for the other 2 shields, so we can copy that. So that should then be right, and that should then be left. So if any of those objects are actually hit, then, and all we need to do is delete object bullet .id, and that's all we need to do. So if it hits the top boundary, which is the box at the top of the screen, if it's the middle, right or left shields, then it will not proceed through. It will simply delete the object, and that will be that. So just to recap, this one will basically position the object. So this is what's causing it to move upwards forevermore. This area of the program is basically saying, does the object exist? Is the object flag set to yes, which we set initially when we created our invaders. If the object bullet and enemy comes in contact, then we then need to set the flag to false, which means our bullet can progress through the object. We then need to hide the object so the user can't see the object. So as far as we're concerned, it's gone. We then need to delete the bullet. We then need to increase the player count, which is the number of aliens attacked. So as soon as that hits 50, we need to reset everything, which will be handled later. Then we need to increase the player's score, and if object exists equals true, we need to do another check because it may have been deleted in the previous one, and then we do another collision check. If the collision has occurred between the boundary and the bullet, the middle shield, the right shield, or the right shield, or the left shield, then we delete the object again. And this means the object is ready to shoot another time. So if we compile it again to make sure it's working correctly. So that's hitting the aliens correctly. And we'll just make sure that all the aliens can be hit. Well, they're up in the row anyway, I won't do all of them literally. And make sure it doesn't go past the top boundary. Yes, I can fire again. Press it a few times under here. We can't actually see the bullet being formed because it's in the red zone already. But if I can fire again, yeah, that's fine. So as you can see, the collision detection is now working correctly. It's destroying enemies. It's obeying the boundary rules. And we now officially have the ability to kill our alien horde descending to Earth. Next, because this is the bullet control function, we're also going to add in some controls for the alien bombs as well. We haven't actually created them yet, so we can't actually test them. We'll put the code in now anyway, and it will be ready to go when we hit that part of the program. So if object exist, enemy, open bracket 0, 0, dot bomb, close bracket, equals true, then we want to, much the same way we did with our previous bullet, only in the opposite direction, what we're going to do is type in position object enemy. Now the 0, 0 is just referring to the first enemy. Because there's only going to be one bomb fired at a time, we're just going to reference the first element in the array. Dot bomb. Object position X, enemy position 0, 0, dot bomb, comma, object position Y, enemy oops, I can't type, that's enemy dot bomb. And because the bombs are falling from the Space Invaders instead of going upwards from the ship, we need to put this into negatives. So minus a bullet dot speed. And finally, object position Z, open bracket, enemy 0,0 dot bomb, and that's basically it. So this is exactly the same thing we did with the Space Invaders. Sorry, the bullet we shot initially. So all we're actually doing here is saying if the enemy dot bomb is true, which is a flag in this case, then we want to move that object down the screen in the same way we did with the bullet ID. And next we're going to set up collision for the bullet as well, or for the alien bomb I should say. And we're going to give it another if statement. So if if object collision enemy open bracket 0,0 close bracket dot bomb comma boundary dot bottom or equals true, or object collision enemy 0,0. In fact, I'm copy and paste that from now on. It's going to appear quite a lot. Or object collision with, what else do we want? We want the middle shield as well. So boundary. I've mistyped that, haven't I? Dot middle shield equals true, or object collision enemy dot bomb and boundary dot left shield equal true, or, and the last one, object collision enemy dot bomb right shield equal true. Then we want to delete object enemy dot bomb, and that's it. So basically the same as before. If the object collides with enemy dot bomb, if the enemy dot bomb object collides with the boundary dot bottom, the boundary dot middle shield, the boundary dot left shield, or the boundary dot right shield, then delete the object enemy dot bomb. So rather than giving bomb.id a name, I've just called it enemy.bomb. And we also need to do a check to see if it's hit the player. So we need another if statement. If object exists, so we check if the enemy.bomb exists, equal true. If object collision enemy.bomb comma player dot id equal true, then decrease player dot lives and delete object enemy dot bomb. So basically, if it hits any of the boundaries, and we just delete. If it hits any of the boundaries, just delete the object. If it hits the player, then we need to delete the object, and we need to decrease the number of player lives. And this will allow us to create a lose condition where the game is possible to lose. Now, obviously, we can't test this right now because the aliens aren't actually firing any bombs. I shouldn't actually have put any brackets here because that's referring to the object ID. It's not actually part of a function. We'll try compiling now, see if I've made any obvious errors. It appears I've got some bracket imbalances. So I've got a bracket there. Need to put in another bracket. And a one there as well. So I think that's correct now. And again, I appear to have missed a bracket here, so... Oh, no, I haven't. Have misspelt collision there. So this is why it's a good idea to always check your code. So that's why it's quite important to always change your code. I've just changed collision as well. So we'll try compiling again. And I think I've missed in another end if. I missed another end if there. And there we go, so it's now working better than it was. So now we know that that code will compile at least, and it's doing the basic things that it was before, so I haven't ruined it. Next we need to actually start moving our invaders, otherwise it's going to be quite a pointless game. So functions, and we want to create a new function. So function move invaders and end function. And we're going to start off with our usual loop for whenever invaders are involved. So for x equals 0, 2 and 9, for y equals 0, 2, 4, next y, oh excuse me, and next x. And then in between there, we need to check if the enemy flag is true. So if enemy x comma y dot flag equals true, and put the end if here. So we're basically running through the loop and asking the question: is the enemy flag set to true? If it is, this means the object exists and we can perform operations on it. If object collision occurs between the enemy that we're currently searching through and the object ID, and a boundary dot left equals true, and enemy 0, 0 dot direction equals 0. So we've got two conditions we need to satisfy that. Another end if as well. And then we need to change the enemy direction. So enemy 0, 0 dot direction equals 1. This will ensure that the next one is triggered. Enemy 0 dot drop equals 1 as well. Now we're enabling this. We could actually say true for that. And we need to increase enemy speed by 0.01. So every time we hit the left or right of the screen, we want to increase the speed. We want to reverse the direction it's currently going, which is the direction thingy. And if drop equals true, then we also want to lower our alien invaders by 5 units on the screen, and this means that our alien invaders will start dropping down the screen rather than just going left and right. So we've done the left boundary, and now we want to do the right boundary. If object collision enemy x, y dot id and a boundary dot right equals true, and enemy 0 dot direction equals 1, then again we want to reverse that direction, so end if there as well. And enemy dot direction equals 0, so we're reversing that quite nicely. And we need to make sure it drops as well, so enemy 0 dot drop equals true. And we will also want to increase the speed, so increase the enemy 0, 0 dot speed by 0.01. Now 0.01 may not seem much, but believe me, as the game progresses, it definitely mounts up. So, I'll just get rid of some of this extra spacing I put in. And now what we're going to do is make a set of decisions, or we're going to use a case in this case, to decide what we should do with the enemy. So select enemy 0, 0 dot direction, end select, because I always forget to put those in if I'm not careful. And we're going to have case 0, end case, if enemy 0, 0 equals 1, oops, I will need to put the drop as well. So if enemy drop equals 1, sorry, if enemy drop equals 1, then we need to do the operation on all the objects. So for x equals 0 to 9, I have to admit I really hate this automatic inserting thing. For y equals 0 to 4, mostly because it's inconsistent. It will do it for some, but not others. And that should also be y and x. And then we need to position object enemy x, y dot id, object position x enemy x, y dot id. I can copy that. Object position y and object position z. Now we also need to make it drop down the y, I think. Yes, we do. So we need to minus that by 5. So minus y by 5. And then that's that. And we then need to write else, give it an alternative, and this ensures it moves even though drop isn't actually equaling 1 at the time. So we need to give, we can actually copy this again, I think. So we copy that, We'll paste it in here. And we don't want it to go down the y-axis this time. We want it to add the current speed of the enemy. So add enemy 0,0 dot speed. And then we'll proceed on to case 1. In fact, really I should keep that consistent and have drop equal true, which is what I set up here. Though 1 would work just as well. So we're going to set up another case now. Case 1, end case. Now all I'm going to do is copy this code here and insert it into case 1. Really hate the spacing on this thing. Don't know what's going wrong with it. Anyway, there we go. And we need to make that a minus instead of a plus, so it's going in the other direction. So as you can see up here, it's plus enemy, and down here it's a negative enemy. Up here is exactly the same because we still want it to go down by 1 line. Apparently I missed out something earlier. I should have put drop in here. There we go. So we'll try compiling that now, see what happens. Right, that's misspelt. That should be enemy. There we go. So whoops. They're dropping a bit fast there, so I made a bit of a mistake somewhere. Of course, I haven't actually reset the enemy.drop, so this one should have after it enemy dot 0,0 dot drop equals false. And I'll need to duplicate that in the next case as well, otherwise we're going to have the same problem. We'll try that again. So there you go. It's now hit the left boundary and it went down. It's hit the right boundary, it's gone down. So this is now looking very much like a Space Invaders kind of movement, isn't it? And of course, while it's moving, we can shoot it. So this is practically a game now. So we'll just close that. Now we'll just make a case default because I always do. Case default end case. And again, we want to call our unexpected error. Function. Move invaders. Comma and enemy comma 0 dot direction. And that will report if any errors come up or if it goes out of bounds. So now we've got that nice hit the wall then go down function running. What we need to do is add in something that says if it hits the lose zone then we lose the game. So we need to do a check for all of them again. So for x equals 0 to 9, x That's going to be y. For y equals 0 to 4. And we're just going to place a little bit of code that says if object collision enemy x comma y dot id comma boundary dot lose and enemy x comma y dot flag equals true. Remember, the enemy has to exist in order to touch the boundary, and if it doesn't, then we don't want to count it, so we need to put that in. And we're also going to create a new function now called reset game. And if it actually hits the red zone, then it's going to be a full reset because the game will be over and we need to be asked if we wish to play again. So this is setting up that lose condition. And of course, before we test this, we need to actually create the reset game function. So function reset game choice string, because it's a string variable. And we need to select choice, end select, case full, end select. And what we basically want to do here is type in center text system dot wres divided by 2 comma system dot hres divided by 2. You lose exclamation mark, press escape to exit or any key to play again. Center text system.wres divided by half, comma system.hres divided by half, put that in a bracket actually, and we also want to subtract 15, so we're not overlaying the other text. That's 15, not 150. And final score plus string player dot score. So what we're basically doing there is giving the final score, telling the user what's happened. We're going to sync that message to the screen. We're going to wait for any key, and then we're going to type in our reset data. So for x equals 0 to 9, for y equals 0 to 4, next y, and between there we need to type in, I really wish it would stop creating nexts, don't need it. Right, and basically we're using the original code that we position the objects with. So position object enemy x comma y dot id 135 minus open bracket x times 30 comma 125 minus y times 30 comma 0. Show object enemy x comma y dot id, enemy x comma y dot flag equals 1. Could also put true there, but 1 would do. Player dot count equals 0. This is code we're going to be using later to determine whether or not all the aliens have been killed. Player dot score equals 0. We want to reset that as well. And player dot lives equals 3. Now we also want another set of conditions for this, so let's create a new one. Did I create an end case there? No, I typed in end select. Whoops. That should be end case. Case set end case. And what we're basically going to do here is reset the positions of them, but nothing else. So what we can do is delete that block of code there, push it into the case area. And what we need to do then is remove the player.score equals 0 and player.lives. We don't want those reset. We just want the counter reset. We want the flags on all the enemies reset, and we want to show all the objects, and this will ensure that everything appears as it should have done originally. And finally, case default end case. You can see why I made this function now. I'm repeating this quite a lot. Unexpected error. Reset game. Choice. And as you can see, it's now going down quite happily. We can shoot our enemies as we're supposed to. So I'm just going to pause the recording, and that will make it go down a bit faster. So when we hit the lose zone, we should get a lose error. So we're almost there now. Hopefully when our aliens hit the or go into the red area, we should get a lose message. There we go. So final score was 40, so it has been keeping track. You lose, escape to press exit, or press any key to press again. So you press any key, as you can see, it all goes back to where it was. Like so. So that's working correctly. So let's go to our main area of the program, and next we need to do the alien bombs. So you're going to create a new function, alien bombs, and end function. Now, to be honest, this one's a bit simplistic, and it could do with a bit more thinking, but it works, even if it's a bit wasteful in some ways. So alien bombs, if object exist 0,0 dot bomb. What am I doing? It might help if I type in enemy there. That makes more sense. So if object exists alien.bomb equals false, then we want to create one. So Make object sphere, enemy, comma 0 dot bomb dot, sorry, comma 5. So this is now made our projectile or bomb. This is the wasteful bit, to be honest. All I've done is put in a very simple loop, repeat, and until, as it's put there. So repeat until enemy x comma y dot flag equals true. X equals RND 9, Y equals RND 4. So what we're basically doing is generating a random number between 0 and 9 and 0 and 4, and then we're saying if that actually exists, if the flag says that this alien is on screen and ready to fire, then it will do. But because it's random, it's, you know, the fewer aliens you got on the screen, the less chances it's going to be of actually getting the alien in question. So if it's going to be a 1 out of 50 chance, so if there's only one alien left, then it's going to be sitting there repeating this until it finds that alien. And there is a better way of doing it, I'm sure. I just haven't put my mind to thinking about it yet. Position object enemy 0, 0 dot bomb, comma object position x enemy open bracket dot id. So enemy x comma y close bracket id close bracket again. Object position y enemy x comma y dot id and object position z enemy x comma y dot id. Yeah, that's right. So basically what we're doing is once we've discovered the alien that's able to fire, we then position the bomb at that location, and we're actually going to drop it down in the same way we did for our player object. We're going to drop that down by 10 units. Now this is a very crude way of doing it. It's not very good at all. There are better ways of doing it. I just haven't written it in time for the Christmas release. I'll probably rewrite this later on. Having said that, it does work. So, color object enemy. We'll give it a nice red color as well, I think. Comma RGB. Oh, I keep spelling the British way. Actually, we'll give it a nice cyan color again. I like cyan, and it's kind of alien-y colour, isn't it? So we'll colour our object cyan, so you've got to watch those little cyan bullets dropping towards you like stones. And what this basically means now is our aliens will now start dropping bombs on our head. So we're going to compile the project and see if it works. There we go. So we've now got those spheres dropping towards the ground. So I'm going to delete those boundaries actually, just to make sure I think what is happening is actually happening. So we'll disable the boundaries. False. With any luck, the bombs will be dropping, and when they hit me, they should vanish. Yeah, so they're not falling through me. That's what I wanted. So it is detecting the collision between the bullets and my ship. So that will be number 3, which means I'll be dead by now. As you can see, they're not falling through the bottom. So, and they're hitting the bottom boundary as well. So that's good. That means everything is working as it should be. And the shields are working as well. They're not falling through the shields. So that's. So what do we need to do next? Next we're going to do the all-important game check. So we'll go back to our functions and we'll write a new function as we always do. Game check. I did get that right, didn't I? Yep, I did get that right. And game check is one of the smallest functions, I'm glad to say. So if player.count equals 50, then reset game, and we're going to pass through the set. If player.lives equals 0, then reset game full. And that's basically it. While we're at it, we might as well add the game text as well, because those are quite short to troubleshoot if anything bad happens. So function game text. So game text, so center text system dot wres divided by 2, so middle of the screen, and we want it 10 units down from the top, or 10 pixels, and score, add string player dot score, and center text system.wres divided by 2, and comma, and system dot height res minus 20, so we're not halving that, comma, lives, add string player dot lives, and that's basically it for that. So I just did a quick compile there, and obviously I've made a mistake there. So I just attempted to compile that and it failed because I forgot to set the lives indicator under the settings. So if we go back here and we set lives to equal 3, we may have a little bit more success. So there we go. So we've now got text on the screen, we've got bombs dropping. So what I want to do is get shot 3 times now. Like so. Once more. Oop. That didn't work. I must have... Oh yes, I disabled it, didn't I? So when I was bugging, I disabled the game check. So we'll try that again. So we'll try that again. Right, so I'll get hit by that. And one more. And I've lost. So that's good. That means I can now lose by getting hit 3 times. But what we need to do now is test the win conditions. So I just need to blow up all these. So I'll just pause you for a minute. So I managed to get us down to the last block, and as you can see, it's pelting me with lots of bullets. And with any luck, if I kill him now, we'll get a nice set reset rather than a full reset. And that didn't work at all, did it? So we need to work out what the problem is here. Does it work a second time if I actually manage to get him? That just seems to crash it, so I'm not sure what I did wrong there. So what I'm going to do now is add that diagnostic block of code, and hopefully that will help me diagnose what the problem is. So we'll add a new function. So what I actually want this to do is select choice. That should be choice, not diagnostics. Right. Case true. End case. Text 10, 10, FPS. Add string. Screen FPS. This will give you a speed indicator of how well the game is performing. For x equals 0 to 9. For y equals 0 to 4. Next y. Next x. Get rid of that extra next. And in between there. And in between there, we type in text 10 plus bracket x times 30, comma 40 plus open bracket y times 30, comma string enemy x comma y dot flag. This indicates the status of all the things of all the. Sorry, this indicates the status of whether or not the aliens should be visible or not. And we're going to add a space in between that, and we're going to add the object ID as well, because it's always useful to know if the IDs have gone wrong. X comma y dot ID. And we're also going to ask for information on text 10 comma 20 comma player ID equals add string player dot ID add bullet ID equals add string bullet.id, and we also want the bombs, so plus alien bomb, no, should be enemy 0,0 dot bomb equals plus string enemy 0,0 dot bomb. I'm just throwing everything in here on the basis that if you're experiencing problems, this may help you. Text 10, 24 40, comma, enemy 0, comma 0 dot speed equals plus string enemy comma 0 dot speed plus enemy comma 0 dot direction plus string enemy 0, comma 0 dot direction. Add actually no, I don't think we need anything else, and just end that with the end case, and then all I'm going to do is go case default and end case, so it does nothing. So basically if choice is true, then it will trigger all this, and if it isn't, then it won't. So diagnostics, and I should set diagnostics up here, so that should be set to true. Save that, compile, apparently it doesn't like that much. Excuse me while I fix my editor. Of course I'm being an idiot there because I've just repeated the name of the whatchamacallit, so I'll just shorten that to diag. What have I done wrong there? I haven't balanced the brackets out properly. I've probably done the same thing there, haven't I? Yep, there's no bracket there either. Oh, and I've also forgot the end select. That didn't work at all. Hang on a sec. That's because of Pratt I am. I actually uncommented it. You can tell I've been at this about 5 hours running. There we go. So we now have the diagnostic data on screen. So what happens when I shoot these enemies? Doesn't look like the flag is changing. Oh yes, they are. And points and stuff are going up. The indicators on the so they are being updated properly. I've had to slow down the game because unfortunately I couldn't keep up with the speed when the video was unpaused. So it looks like what's happening is that the data isn't being reset correctly. So as you can see, all the zeros are still there. There's only a couple of ones, so we'll have a look at that function now. And of course, if you look why and see what I've done, it's because I haven't actually put any of the for and next in. So it's only been performing all the operations I wanted it to on the first object. Right, so let's try that again, shall we? And with a bit of luck, I'll have got it right this time. So that's what I forgot to do. So now's the moment of truth. We'll see if the fix has had the desired result. I just missed it. There we go. So that is now looking a lot more healthy. The lives are going down, and this is basically a full version of Primitive Invaders ready to go. As usual, I will publish the source code eventually. It's the one thing I always forget to do by the time I've uploaded and converted and video edited. I always forget to upload the source code, so hopefully this time I won't forget. But this is basically how you make a full game of Space Invaders. What I'll definitely do is put all this source code into rolling credits like I did in the last one, so you'll be able to reference it there as well. But I hope you've enjoyed the tutorial. I hope you bared with me, and there were some dodgy moments there where I made some rather horrible mistakes. But we got there in the end. It's now fully working. Again, I'll issue the code eventually, so you can download it for yourself, or you can just copy it directly off the video. I hope you've enjoyed the tutorial. I hope you'll enjoy playing Space Invaders, and I'll leave you with a full video capture of the game in action.